All right, the second part of this lesson is about the truth tables, the and the or truth table, and how we can implement a y-intercept into our equation. All right, so that's the idea. Let's start off with just remembering what the truth tables were. So we had and if we just looked at x1 and x2, we know 0, 0, 0, 1, 1, 1, 0, and 1, 1 would lead to x1 and x2 would lead to 0, 0, 0, 1. But what we said last time was we needed another, what's called a bias in the world of perceptron / neural networks. This is called a bias, and it always contains a 1 because you want to always include that W0 weight in there. And the problem that we discovered was if we were to put on the chart the zeros and the ones in red and green, so this would be my only one at 1, 1, and my other ones would be, so this would be x1, this one would be x2, and we would note that the only place, so there's no way for me to write or to draw in starting from 0. Starting from 0, there's no way for us to, here, let me, pin mode. All right, so we're 0, we're 0. There's no way to separate the reds and greens unless we have a y-intercept. So that's the idea there. That's why this piece becomes important. What does that model look like? Well, it's just x1, x0, x2, all going into a node, and this is an activation unit, so it's node 1. It's going to have an activation function associated with it. The very simple activation function that we're going to use for today is simply just the same one that you used last night, so it's going to be a 0 or a 1, and this is if sum of wi xi is less than 0, and this is if wi xi is greater than 0, then we get that. And so remember, I goes from 0 to 2, I goes from 0 to 2, and so this little step function will allow us to have a 0 or a 1 depending on what happens over here. So that's the and if you could do the same thing with the or. Again, you'd have an x0, an x1, and an x2, and we're talking about x1 or x2, and 0, 0, 0, 1, 1, 0, and 1, 1. All of these are 1s. And we would have a 0 and then the rest 1s. And again, it comes to the same deal. You can't separate without a y-intercept. All right, so let's jump over to R and start. So jump over to R and start using this information. So the only thing I have right now, let me just delete this thing. So the only thing I have right now is the perceptron, the train, and the show results, and the fact that we're using Procma from the last video. So I didn't want to start from scratch in this video because we're going to be basically doing the same kind of stuff. And so I'm going to, let's see, we can do show result. So I will highlight this entire thing here. Let me delete all of these pictures. Control L, and let's start from scratch over here. Control Enter. So we get our perceptron, our show results, and then let's train and Boolean a truth table. What does an and truth table look like? First row, so x would be 0, 0, oh no, sorry, it'd be a 1. Remember, x0 is always 1, and then you put a 0, 0 in, and you get y is equal to 0. And then w is equal to train. W, you got to put in w, we got to put in y, which we did in the learning rate. So I got to initialize w, so we're just going to let that be 1, 1, 1, and my learning rate is going to be 0.3. And these are just ones that I arbitrarily made up. You can certainly experiment with them. We'll get it. So we're putting in a w, and we're getting out a w from our train. And we need to print it. So let's print w. That'll be one of them. And then I'm just going to copy paste, Control C. It's in there. So 0, 1, that's also going to be a 0. 1, 0, so this would be 1, 0. That's also going to be a 0. And 1, 1, and that's going to be our only 1. Let's highlight these, Control Enter, Control Enter. Just keep doing it, and then finally you get to this one down here where you'll see it's a negative 0.8 and a 0.7, 0.4, and we want to see what that looks like. So if I threw in 1, 0, 0, I mean, if we put in 0, 0, we'd obviously get 0. I mean, we're going to get these, but I just want to see what this thing looks like. So we need to show result. Let's put this one in, Control Enter. Doesn't like that because I need a 1 at the beginning here. So remember this thing. So I'm bringing the x to y, and I want to show the result, and that's what we get. So remember, white was 0 and black was 1. So you get a 0 here, you get a 0 here, you get a 0 here, and you get a 1 up at 1, 1. So we could go back in and we could retrain this thing to be the OR. So if you remember, that's a 1, that's a 1. So this is 0 or 0 is a 0, 0 or 1 is a 1, 1 or 0 is a 1. Okay, so Boolean logic applies. And we could highlight this, Control Enter, Control Enter, Control Enter. It looks like we have converged. Converged after 1. Looks like it made it converge after just 1. Let's see what that looks like. All right, so you see that this is a 1, this is a 1, this is a 1, and that's a 0 down here. So it's doing what we think it should be doing. All right, so the next part, so let's go back, let's stop sharing this one and go back to OneNote, is talking about H's and T's. And so real quick, let's just describe what we're talking about with these H's and T's. It's just a 3x3 little area. So let's draw a line here. And so if you were given this 3x3 pixels, we call it pixels. So it looks like maybe we're playing tic-tac-toe. I'm going to call this 1, 2, 3, 4, 5, 6, 7, 8, 9. And so let me do 2 of these. So what I'm trying to do is figure out if some of my pixels were not filled in, would it look more like an H or more like a T? So again, we're going to put numbers inside this thing, and these numbers correspond to places in the vector that we're going to pass in. So we're going to have a vector. I'll call this one, we'll call it heads. We'll call the first one heads, and it's going to be equal to a vector. Let's see, heads would be 1, 0, 1, 1, 1, 1, and 1, 0, 1. And why is that? Because I'm putting a 1 here in this one. So this corresponds to 1, 2, 3, 4, 5, 6, 7, 8, 9. And all we're doing is going into pixel number 1, and if there's a 1 there, I'm filling it in. If there's a 0, I'm gonna let it go. So we put in fill this sucker in, fill this one in, fill that one in, fill that one in, and filling this one in and filling that one in. So that looks, hopefully, to you, it looks like an H. And we could do the same thing with the tails. So come over here to tails, and that's going to be, let's see, it's a 1, 1, 1 up top, and then a 0, 1, 0, and then a 0, 1, 0. So again, I'll do this one in red. 1, 2, 3, 4, 5, 6, 7, 8, 9, and sort of fill those in over there. We get 1, 2, 3, 4, 5, and 8. All right. So this one would look like, hopefully, a tail to use. All right. So what we want to do then is we want to train the network to know what an H and what a T looks like. And so what would that look like as far as the Perceptron network? It would be, here, I'm going to need 9 of these suckers. So this is the input layer. So we'll let that be 0, 1. Actually, we need 10 of them. 2, 3, 4, all the way. All right. Yeah, they progressively got smaller. I don't like the way any of that looks. So we're going to have to start over. All right. So 1, 0. All right, now I'm going to put circles around them to represent our input nodes. So now we're getting a little bit more higher up problem, if you will. So I'm going to throw in x1 coming into the input node, and so on and so forth. Right? These, so this x0, actually it's not even x0, it's just 1. So 1s are always going to go into there, and then these will all feed into my 1 final layer, which has an activation function associated with it. And so this would be W0, W1, W2, and so on and so forth, all the way to the 9th one, W9. And so same idea. It's not, doesn't really change that much. You're either going to get an H or a T, and if, we'll call it W0 plus, actually, we can still do that summation sign. So it'd be a 0 if the sums from Wi x sub I is less than 0, and then 1 if the sum Wi x sub I is greater than 0. We want to model this in R as well. So the way that I'm going to do it is just simply come up with the same thing that we've done here in the past, is I'm going to say what a heads look like, and then, oh, I forgot to say if this is an H or a T. So if it's greater than 0, I'm going to let this be an H, and if it's less than 0, I'm going to let that be a tail. So this heads, this vector here, looks more like a heads, and this vector here, I'm sorry, it looks more like a 1, and this one's going to be trained to be 0s. So if it looks closer to this guy, then it's going to be 0s. All right, let's go to R. And there's a couple things I want to change in here. I don't want to be worried about always trying to get back to my adding the 1 in, if you will. So I just want this Perceptron network to go ahead and calculate with that 1. So if we just do this, if we set C1 comma X, then that should work. And then here, in the train, think about this for a second. So I want to train, I'm going to put in, okay, so I'm going to put in some X, but I don't want to have to worry about putting the 1 in. So I'm just going to let that X equal same thing, X or 1 comma X. Put in the 1 at the beginning every single time. And then we don't have to do this one anymore when we go to show it. Although it's probably not going to be very easily shown. We're going to have to come up with a different way of showing that. All right, so let's go to our R notebook and let's just walk through what we've done in that. So I'm going to stop sharing that. We're going to go to our R notebook. I'm going to share. So as you're sort of walking through this thing, you can see some of the things that we've done in the video today. But in addition to that, you'll see the head and tail. And this is what I was trying to draw out a second ago in the OneNote. So I did this show image thing, and I didn't want to reproduce this thing in our R. So let's just see what that looks like. So what this first option things does is it makes the graphs a little bit smaller. The tail, that should be exactly the same 1s and 0s that we had before. So what does the tail look like? It just looks like a T. What does the head look like? It looks just like an H. And you come down, and then you can see that I put in the 1 in there, and I put the 1 on that one as well, just like we did in the Shift Enter. Right, so what we've done here is set the learning rate 0 to 0.3. We've initialized our W's with just a bunch of 1s, and there's 10 of them. And then we want to train, and that's not completely done yet, or we haven't seen it. So so there you go. So now I did it 4 or 5 times, and you can see that there's no change from one time to the next. So I feel pretty comfortable that we're in a position where this has been trained, and now we can put in different values for our example. So I called this example 1, and all it was missing was one little pixel. And when it's missing one little pixel, the model says the picture is an H, and all that means is the perceptron, when we put in EX1, when we put in this sucker into the thing, it equals 1, and then therefore an H is predicted. And now this next piece just goes through and makes a bunch of examples. This first line represents an example, the second line represents an example, and so on and so forth. And then let's just see what happens to all of these different examples. And so maybe, yeah, this one's missing 2 pixels now, and it still says it's an H. This one's missing 1, 2, 3 pixels, and it still says it's an H. This one's missing only 1 pixel here, it says it's a T. This one's missing 1 pixel in the middle, says it's a T. Let's see, we're missing just 2 now, it says it's an H. And you can kind of see what's going on here, right? I'm missing 2 pixels now, it says it's a T. And missing 1 in the middle. Is that one that we've done before? No, we're missing 1 in the, okay, so it's just missing that guy right there, and it says it's a T. So now you can see that the model, the weights that we trained above up here, these weights that are associated with training the H and the T, can now do the multiplication and figure out which ones are pretty close to the H's and T's. So in other words, you don't have to have all the pixels. If you're trying to do some kind of image recognition, you could use this type of model in order to do it, but for very simple ones. The object of next class is to sort of step up the game just a little bit, but in order to be able to do that, you got to understand what's going on in this one. Well, that's all I got. I'll see you next time.